Hello and welcome to the Sustainable Materials Management Webinar Series, a joint effort between the National Recycling Coalition and the Pennsylvania Recycling Market Center. My name is Wayne Bowen. I'm the Program Manager for the Recycling Market Center and will serve as your moderator today. Today's topic is a continuation of the June 2019 webinar titled Transforming the Solid Waste Sector. The focus on today will be on EcoHub. Please note that at Pennsylvania Recycling Market Center, its affiliates and funders, and the National Recycling Coalition assume no liability resulting from the use of any information provided during this webinar. The webinar is only provided as an informational tool and no discrimination is attendant and no endorsement by these organizations is implied. Our presenter today is Rob Watson, who I will introduce in a moment. Following the presentation, we will conduct a question and answer session. If you have a question or comment, please use the Q&A feature located in the control panel on your screen. You may also use the chat feature to request assistance if you're experiencing technical difficulties during the webinar. And please note that an edited version of the webinar will be made available for viewing via YouTube links on the National Recycling Coalition and Pennsylvania Recycling Market Center websites. And now I'm pleased to introduce Rob Watson. Rob is an international leader in market transformation in green buildings. Rob is known as the founding father of the Leadership in Energy and Environmental Design, also known as LEED. And under Rob's direction, LEED became the largest and fastest growing international green building standard. Rob has also developed the SWEET model, that's what was the topic of the June 2019 webinar. So at this point, I'm going to turn the program over to Rob, and the presentation is yours, Rob.
Thank you very much, Wayne. I appreciate you having me on as on the show, and I appreciate everybody taking time out of their Thursday to explore this very interesting topic. Clearly, you know, as the global protests have shown, people are very interested in topics around the environment, and waste is an absolutely crucial sector, not only for mitigating global warming, but for protecting human health and safety. So I'm going to be talking about EcoHub, and you know, we're trying to propose a new industry model for recycling, which is, as someone who started their career, or at least my first job as a sixth grader, was helping people at the Tiburon, California drop-off recycling center figure out which bin to put things in. Fast forward 50 years later almost, and we're still trying to figure out which bin to put things in. We all know conceptually that just throwing things away is A, there is no away, and B, doesn't make sense economically, doesn't make sense environmentally. So the question is, how can we do something that we know is the right thing to do in the most effective and cost-effective way possible? Just stepping back for a minute, I mentioned climate change. You know, we are entering into a completely new era. We've seen the historical temperature record continue to climb, but the past record is absolutely no indication of what's coming. Literally, if we go forward about 100 years, the things that we're talking about are literally off the charts. And so, you know, we've already seen the increasing frequency and intensity of storms. We've seen sea level rising. We have coral bleaching. There are a lot of elements that are beginning to give us death by 1,000 cuts. And these impacts will only accelerate as we put a heavier and heavier blanket of carbon dioxide onto the atmosphere. Now, we have some time before we are sort of past the point of no return, which is why we see such urgency now in trying to promote and implement measures that will slow down this growth and eventually reverse the growth of carbon dioxide. So in about 5 years, we need to start turning the corner, and then we have another 20, maybe 30 years to largely decarbonize the economy. The good news is that most of this is technically quite feasible, and with small tweaks, economically quite feasible as well. If we look at where greenhouse gas emissions come in the United States, it's mostly buildings, followed by transportation and industry, and then agriculture. And sometimes looking at a global problem of this magnitude can seem like saving the starfish. It could be considered a largely impossible task. And in fact, a little girl was seen throwing starfish into the water, and she was approached and said, "Why are you wasting your time? You can't possibly make a difference to all these starfish." And the little girl just replied as she threw a starfish back into the water, she says, "It matters to this one." And that's essentially what we as passengers on Spaceship Earth need to do. We need to take the heroic action that is the right thing to do no matter what. And if we all act that way, we have an ability to turn around this challenge that faces certainly life as we know it, and quite potentially whether humanity will continue to be a viable species on this planet. The planet's not going to have any problems surviving after us. It's been through snowball Earth, asteroid impacts, etc. So the Earth is going to be fine. The question is whether we're going to be around to enjoy its myriad benefits. So rather than save the whales, on my office wall, I have a poster that says, "Save the humans." And that's what we're here to do today. So if we look at the potential for sustainable materials management, it represents up to a third of, we could reduce through an integrated sustainable materials management structure, we could reduce almost a third, about a third of industrial emissions. And that's about 9% of total US greenhouse gas emissions. That's a very significant piece. And that's why the work that you all on the call, regardless of where you are, makes such a big difference. And it's very important that we continue doing what we're doing, but hopefully do it better. We sort of have this idea that if something needs to be separated, that it's up to humans to do it. And if, for example, we recognize that organics are problematic from a lot of perspectives. And so a lot of people are saying, well, we just have to separate, we just have to get people to separate the organics. But it's easy enough to do with yard waste when you've got a backyard composting. It's a lot harder to do when you start adding food waste to it. It becomes a nuisance on numerous levels. And I don't think the very prescient and arch cartoon by Roz Chaz from probably 30 years ago now, Recycling in Hell, is the way we need to go. So what I'd like to do is, talk about, in addition to the sweep later on, just talk about how we transform the sector. So clearly, we need to think differently. We need to stop thinking that there is good garbage and bad garbage, and that good garbage gets separated by people, and bad garbage, well, we do whatever we can with it. And it's not only the afterlife things that we need to rethink. We need to rethink the entire supply chain, and that's where sustainable SMM, or sustainable materials management, comes in, because it looks at the whole life cycle, and it looks to avoid the extraction of new materials and in favor of replenishing it from existing materials. So what we need to do is look at discarded materials not as waste, but as resources that are at the point of reuse in their lifetime. So one of the big problems is that the structure of the industry is both technically and economically, it's last century, frankly. And that's exacerbated by the fact that we rely on unreliable humans to do the very crucial piece of separation. Our thesis in EcoHub, which is what I will talk about going forward, is that physics is a better way of separating materials. Everything in the waste stream has density, dimension, and optical properties. And by applying these physical attributes, or by taking advantage of machines that sort materials based on these physical attributes enough times, you can take the entire waste stream, not just the quote good garbage, but everything in the waste stream, and separate it into its constituent parts. And then finally, we need to figure out how to transform the market. Not only do we need new business models that stop relying on unreliable commodity markets, which are hampered by unreliable supply and unreliable quality. In addition, we need a framework for how actually sustainable materials management and diversion and recycling and all these things are actually defined. If you look from one jurisdiction to a next, there are very few recycling programs that define materials in the same way, very few that define diversion in the same way. And so it's very hard to come up with policies that can be applied consistently, which is very important with our highly mobile population. So sustainable materials management is gaining currency. I thank my colleagues at Waste Management who are on the steering committee of SWEEP with me for supplying this slide. And basically, it's integrating not only the design and production of materials in a slightly new way that emphasizes the use of recovered materials over extracted materials, but it also recovers the materials in a way that's comprehensive and puts them into an infrastructure that is designed for them. So not only do we need things that are designed for recycling, we need a system that can take materials that are collected and effectively turn it into new products. And people can say, well, that's what the recycling structure does today. And that's true to the extent that it addresses approximately a third of the waste stream. In Europe, where people are much more assiduous about separating, the number Europe-wide is only about 40%. And yes, there are outliers like Denmark and Seattle, et cetera. But writ large, most of everything we produce is disposed of, whether it's disposed of in a hole or whether it's sent up a chimney in the form of heat. And so we need a new way of recapturing the molecules in the waste stream, which don't change that much from the time that they're disposed, and can effectively be reconfigured if we have the right infrastructure for capturing them and for transforming them. So I'm going to give a little a short promo slide video about EcoHub, and then go into a little bit more details, and then spend a couple minutes on SWEEP, and then we'll do Q&A. So the three breakthroughs is that conceptually, there's no good garbage and bad garbage. Obviously, there are things that have more value economically when you replenish them or when you repurpose them. But generally, everything in the waste stream can be profitably turned into a new product or clean energy using existing technologies, if only we could cost effectively separate the materials. And that's really where, because the other conceptual flaw with the current system is that we rely on consumers who either don't care enough and don't put things that should be in the recycling bin, or they care too much and they basically say, it's plastic, it should be recyclable, so I'm going to put it in the bin to send a message. And obviously that ends up as contamination because downstream we don't know what to do with it, or our equipment isn't designed to handle it, and therefore it ends up mucking things up. The max diverter, which is at the core of the EcoHub, is designed and purpose-built to take everything in the waste stream and separate it into up to 40 clean and consistent material streams. We can separate into 10 grades of paper, 8 grades of plastic, glass by color if needed. The organics can be separated, yard waste from food waste. We separate mixed dry organics into their constituent parts. And each of these materials, once separated, goes into a back-end facility that is purpose-built to handle the quality and quantity of the material coming out of the EcoHub. A typical EcoHub can process about 2,000 tons per day, which is about 624,000 tons per year on a 6-day week. And it's designed to operate 20 hours a day with 4 hours of hot maintenance and 24 hours of cold maintenance over the weekend. So, you know, it's designed to, it's a large scale facility. We can do 1,000-ton machines, but on the back end, for example, you know, 2,000 tons a day is about enough to produce about 500 tons a day of fiber. And that's, you know, sort of the minimum level where economies of scale in paper reclamation make economic sense. So that's one of the reasons we're looking at larger scale facilities initially because of the economies of scale. In terms of selling the product, we're not selling bales of fiber or plastic or you know, bins of compost, etc. We're selling actual recycled paper and virgin-like plastic, or you know, fertilizer, clean energy, clean power, low sulfur diesel, etc., as our offtakes. And because we can produce and guarantee clean and consistent material streams, because we're capturing everything in the recycling within the waste shed that we're covering, we can develop long-term offtakes with large consumers, which we have done in several cases. So technologically, basically, EcoHub is focused around the max diverter recovery system. Everything in the max diverter has been in the field and proven with years, if not decades, of use. And what makes EcoHub and the max diverter different is that we have sequenced them in such a way to be able to separate everything in the waste stream. Not unlike words that when strung together can be immortal poetry or instantly forgettable, proven things, it makes a big difference the way they are sequenced and ordered. So by the sequencing, everything is separated by density, dimension, and optical properties. As I mentioned, we can create up to 40 clean and consistent material streams depending upon what our off-takers are looking for. Obviously, we're not going to add material streams, which adds capital cost if we don't need to. So, you know, we may just have, you know, 3 or 4 grades of paper instead of the 10 that we're capable of. And it may be that, you know, depending on our back-end offtake in a particular waste shed, it may not make sense to separate as many plastic, or maybe glass just needs to be mixed instead of separated by color. So these are the things that we look at when we go into each waste shed that we want to put an EcoHub. And then our system is guaranteed at 3 levels to separate 95% of the materials coming in into clean and consistent material streams. Each of these material streams is guaranteed to be 90 to 95% pure, and the equipment and the system are guaranteed to be 97% uptime. And the people making these guarantees are the equipment manufacturers, you know, Vecoplan, Steinert, Amut, a lot of the, you know, usual suspects, you know, very, very high-end equipment, mostly European. And then Stadler, which is our system integrator, 250-year-old company from Europe, largest system integrator in the world and the most experienced. They guarantee the performance. We are probably the only system that has that performance guaranteed in writing. And then our EPC contractor, engineering, procurement, and construction, is Grupo ACS, which is a $50 billion industrial infrastructure construction company, and the largest private construction company in the world. And all of these, each manufacturer, the system integrator, and the EPC contractor have all reviewed the engineering, and they've reversed engineering, they've gone through the process flow, and they know the performance of the equipment. They know based on what comes into a certain piece of equipment, they know what's going to come out, and they know because when you match inflow with outflow and you do that across the whole waste stream, you basically all the numbers add up, that everything that mixed waste comes in and 40 clean and consistent material streams come out, and that's why they're willing to guarantee it. So when anybody comes in with an outsized claim of performance, there's instant and natural and certainly understandable skepticism. Although the thing that sort of cracks me up is that you have a lot of jurisdictions that are in the 20 to 30% recycling range, and they're going to set a zero waste or a 75% diversion goal, and they're like, and make sure that the technology is proven. And the reality is that if existing technology and existing structures could divert that much, then they would be doing so already, because if they were doing it properly, it would make economic sense and it would be feasible and it would be done already. But the fact is that there isn't a single jurisdiction, Seattle and San Francisco and Los Angeles included, that are anywhere near that 75 to 80% diversion rate, except maybe in a couple of very tiny verticals. And we sort of have this sort of industry-wide happy talk about how much is actually happening. But when you actually look at the numbers, the numbers absolutely do not match the rhetoric. So, it's a question of, do we want to, take a risk on something that is like putting wheels on luggage, or do we want to pretend something that's proven not to work is going to actually achieve diversion rates 2 to 3x what's actually out there, again, out there currently. And, we are surrounded by impossible things, things that had never been done before. And in fact, many times when these new technologies are introduced, they are roundly criticized and ridiculed. So this telephone has too many shortcomings to be seriously considered as a means of communication. This device is inherently of no value to us. And of course, Western Union would say that. Or, the horse is here to stay, but the automobile is only a novelty, a fad. And thank goodness Henry Ford did not listen to the president of the very wise and very serious president of the Michigan Savings Bank. And of course, we all know that television won't last, because people will soon get tired of staring at a plywood box every night. And well, we know how that turned out. And of course, there's absolutely no reason for any individual to have a computer in his home, he said, talking into his computer from his home. So, things that are obvious later are often seen with ridicule. And all things like EcoHub asked is that people take a serious look. There isn't a single thing like wheels and luggage in our system that is unproven. All we've done is put it together in a new way. And that's the, quote, radical innovation. So if we take mixed waste and we turn it into clean and consistent material streams with off-takers, and depending upon the mix of waste, which can vary from jurisdiction to jurisdiction, we will tune, make small tweaks in the max diverter system, maybe capacity here, maybe a little bit less capacity there, and similarly on the end, choices of materials. The back end is proven as well, and the innovation in EcoHub is basically a real estate play. So rather than sending it to an existing facility, which may or may not be able to handle the material specification coming out of our EcoHub, we're going to build our own facility using proven technology with proven equipment and known off-takers to handle our spec. And that's how I know that small bits of contamination in the fiber aren't going to make a difference, because our system is going to be designed to handle it. Things that, if fiber gets smeared with ketchup because it's next to a hamburger, well, that's going to fall into the composting heap, and it's not going to end up messing up the fiber, because it's going to have a different mix of density properties. So a lot of people just say, oh, well, the max diverter is just a dirty MRF, right? And we know that dirty MRFs don't do very well. We've got the IREP in Montgomery, and that failed, and they're trying to do it again. It's probably going to fail again. But we know that mixed waste processing doesn't work. And when I was doing green buildings, I frequently said the problem with green buildings is not that people went too far, is that they didn't go far enough. And that's kind of the problem with dirty MRFs, because dirty MRFs are designed to do they're designed to do one thing, which is to skim recyclables from mixed waste. They're not designed to separate mixed waste into constituent parts. They're designed to skim a fraction of the materials. And so you end up with almost the worst of both worlds. You end up with materials that, because you're not touching it very many times, you end up with relatively poor quality. And then you end up with a 60%, 70% of still undistinguished mass, which you hope that you can turn into something that has some economic value, like a fuel. But because the constituents parts of that can vary so highly, getting a reliable and consistent fuel type can be very difficult. And because that consistency can be difficult to develop, it can be expensive to create a consistent fuel pellet quality, and it ends up being fairly low price. So if you look at a schematic of the max diverter, this is basically the Montgomery IREP constituent parts overlaid on it, and you see that there are 14 steps. But if you look at the max diverter, you have all of the normal suspect steps, but you have 58 sorting steps. There are several density and dimension steps that we put in between the optical steps, and we introduce a lot more optical steps to get the material purity and the quality that we want. And again, because we are getting everything in the waste stream, we can produce enough volumes to have a bunch of stuff on the back end, not just a single remaining thing. So the separation piece, I've already mentioned that all the back-end technologies are in use everywhere around the world, and all we're doing is locating them on the back end. The mixed waste recovery, we've done it in fact, the impetus for this was the Roseville, California mixed waste separation plant that gets about 70% diversion. And when we went through the one bin for all RFP in Houston, we were the unanimous choice and selected the winner of that proposal. The South Coast Industrial Development Authority gave us a $650 million bond, and then to implement it. But in negotiations with the city, things went sideways for reasons I can't talk about right now, but will come out and are coming out during the election. And that we probably will see an EcoHub in Houston before too long. And the idea of EcoHub and having these eco-industrial campuses that are almost like co-ops is gaining a lot of traction. We're seeing things in Phoenix and in Kent County and Chester County looking for these eco-industrial things. From a project development perspective, it's nice to let 1,000 flowers bloom. But the problem with those kinds of sort of having a bunch of different parties coming in, you've got individual negotiations, individual timelines, individual financing headaches, individual contracting headaches, and just and something that might be optimized for a single component but significantly sub-optimized for the entire waste stream. And what EcoHub does is it looks at optimizing the environmental and economic value of the entire waste stream. We're optimizing under the integral as opposed to optimizing the derivative of a single piece of it. And that's why this comprehensive, integrated, systematic approach is going to be significantly easier to do and significantly more successful than the piecemeal efforts that are currently being contemplated. So I mentioned the one bin, for the one big bin project in Roseville, California. It's a lot more manual than EcoHub is because this project was designed and developed about 15 years ago. I'm going to show a very short video that talks about the, how the system works and what its performance is. So let me just fire this up, full screen mode. Hopefully you can hear.
Well, in Placer County, we like to say it's recycling and disposal made easy because it really is as simple as residents putting their garbage and recycling in one bin, and we do the recycling for you, and we call it the One Big Bin program. I'm Chris Hansen, the senior planner with Placer County's Waste and Recycling Program. Right now, we're at the Western Placer Waste Management Authority's Material Recovery Facility in Roseville, and we like to call it the MRF. Once residents put their garbage on the street, it's going to be picked up by their local garbage hauler, and depending on where they live, it'll be taken to one of the 2 materials recovery facilities in the county. In Eastern Placer County, we have the Eastern Regional Materials Recovery Facility in the Tahoe area. In the Western Placer County, the garbage is taken to the Western Placer Waste Management Authority facility here in Roseville, which is where we are today. Once the material comes to the facility, the first thing that happens is the garbage hauler will dump it on the facility floor. And that's where actually some of the sorting begins. If there's larger materials like lumber or scrap metal, they'll pull that out at the beginning, and then a loader will load up the waste onto conveyor belts while it'll start to go through the process. Some of the initial sorting that's done is done by screens. We have a variety of screens that will sort the material by dimension or by size, by weight. For example, metals and heavier materials will go one direction, and they'll pass through a series of magnets. We actually have very large magnets that hover over the conveyor belts, and they'll pull out any magnetic materials. So after the mechanical sorting, the material is pretty well sorted by the time it reaches the people that work at the MRF, the hand sorters. And they're still a very significant part of this facility because we like to say there really is no substitute for the human eye, as well as their knowledge of what's recyclable and not. They're looking for specific material types. So one sorter might be assigned to paper and lightweight plastics. And so as the material goes by, they'll be picking out the paper, the plastics, and putting them in a chute. And from there, that chute goes to a bunker where the material is then bundled and baled for recycling. So one question we get a lot is about papers. If paper is thrown in with the rest of your garbage, can it still be recycled? And the short answer to that is yes. So sometimes paper does come in that's maybe dirty or messy in some fashion, and that's okay. We're able to recycle that. One of the more interesting technologies at this facility is the eddy current separator. And that handles some of the metal items that are picked up by the magnets, such as aluminum cans, and essentially knocks them off one conveyor belt into another where it can be baled for recycling. Probably one of the biggest benefits to the One Big Bin system is that's just easy on our residents. People don't have to memorize what's recyclable and what's not. We do that for you. In some areas, people are expected to separate their recycling from their garbage, and quite simply, not everybody is going to do that. But with our system, 100% of our residents are participating in the recycling program, whether they know it or not. There are also larger, broader environmental benefits to our system. Our haulers are able to collect the material in one truck on one route, and that's fewer trucks on the road and fewer greenhouse gas emissions. We're proud to say that the One Big Bin system is very effective. The state law requires that all cities and counties divert from landfills at least 50% of its waste. And here, Placer County-wide, we're recycling more like 68 to 72% annually. The recycling is important to us. We realize this is a unique system, but we want to make it easy for you and effective. It's just one way we're doing our part to protect the environment in Placer County.
Okay, so let me just get rid of this guy and go back to this. So, due respect to Placer County, but in fact, opticals are significantly better at distinguishing different kinds of plastics than the human eye. You can't distinguish red LDPE from red HDPE, and that, or PET from HDPE, and we get these dyed plastics all the time, and so the IR or UV signature is different, and so we can separate those things very easily, not only coming out of the max diverter, but also once we go into post-processing, in pelletizing, there will be a washing and further sorting phase so that we get the 99% plus purity that off-takers like P&G or Colgate are looking for in their materials when they're specifying recycled content. So if you look at the modern plants, Stadler continues to be, as our system integrator, continues to be implementing and proving out our system in pieces around the world, proving the sequencing, proving the efficacy of the ability to sort in an automated fashion. The plant in Oslo, Norway has 4 staff people because everything is completely automated and very, very high quality. The collection system is a little bit different. It's a colored bag system, so it's not exactly mappable. But what the facility in Oslo does show is that the density dimension optical sorting will take materials and create 95% pure machine, 95% pure materials. And then in Granada in 2015, Stadler designed the exact sequencing of the max diverter in their Eco Central, and the facility is an MBT facility in part because they didn't want to violate our patents, which cover 2 or more end uses coming out of a mixed waste sorting system. But they're taking in about 1,500 tons a day and achieving 95% separation. And then they take all the plastic and all the paper, and then then the organics go into MBT, and then the paper and plastic go to a separate facility which has the exact max diverter sequencing, and it does exactly what the max diverter is designed to do. And so Stadler is proving pieces of the system, and that's why they're willing to give us the guarantees. Another interesting piece of the max diverter is that it's all closed loop. We have a filtration system that we would use on the anaerobic digestion that separates the water molecules from the solids. This system can also be used to purify the water from pulping, the water from plastic washing, glass washing, etc. So basically 95% of the water is reused on site, and the purity system, which was tested in Pennsylvania, in fact, on mine tailing pits, basically took heavy metals, chloride, other organic pollutants from triple or 4-digit levels per million and down to single digits below EPA requirements. So it's a very, very effective and cost-effective system, low energy, and it uses a very highly effective and patented technology. This can also be used to clean up leachate if people are interested. So we're really trying to think closed loop, not only in terms of our position in the waste system, but also within the internal things. So I've spent a lot of time on where it's been done before. I'm not going to continue beating that drum. In terms of offtake, in addition to several large industrial companies that we have tentative offtakes with, we also have a promise from Cellmark, which is one of the largest material and commodity broker firms, not only to sell our products, but also to take some aspects of the clean energy and help us market that. So this is one of the things that is very important for us to have if we're going to get the $400 to $500 million that it would take to build an EcoHub. And so this is one of the things that anchors the economics of it. So I've mentioned the 3-level guarantee, so I'm not going to repeat that. We have, again, a lot of partners that are very interested in EcoHub and ready to make it happen once we get a waste supply agreement. So the seed crystal to get EcoHub going in its full integrated fashion is a long-term waste supply agreement of 2,000 tons a day. And we can guarantee that our processing fee will be at least 20% below current processing fees, and the individual jurisdictions can decide whether or not they want to consolidate routes now or later. We're very happy to take single stream recycling and build out the back end as we bring in mixed waste more and more. So there is a way of staging this so that current recycling regimes are not disrupted, and that we don't have a fight over whether or not we're killing recycling. And this can be very effectively done both technically and economically. So we've got flexibility to deal with a lot of different configurations in terms of waste supply. We are the unique global patent holder for mixed waste separation and processing into products. Sadly, there are some violating facilities out there that eventually will hear from us. We're not looking for a fight, but we will protect our intellectual property. We'd be much happier to partner with those groups. And I would be happy to provide the patent portfolio to anybody who wants to look at them and see whether they might be potentially liable for an action in the future. So we're not content just to stay with current state-of-the-art materials recovery. We want to look to the next generation to get to even greater flexibility. If we can break the materials down into their constituent atoms, we have a lot more flexibility what we can do. Our chief scientist has 35 years at NASA, and based on technologies that he helped develop and used in the space program, we have a way of separating materials into their constituent atoms, which are principally carbon, hydrogen, and oxygen, plus some advancements in anaerobic digestion and other technologies that will allow us to move to even higher value separation and even greater production of clean energy. So, we could have a literally zero emission facility, taking elemental carbon and turning it into high value carbon based products like carbon fiber, nanotubes, graphene, et cetera. And that could launch an entire lightweight materials revolution and create a new carbon economy, all from materials that have been discarded. So economically, our modeling, which is quite conservative, shows very good economic performance from a private investment of about $500 million, which we're not seeking any subsidies for from the government, or $400 million for the second generation back end. We can create between 1,300 and 2,000 jobs. We can generate between 1.2 and 2.4 billion dollars worth of macroeconomic activity. Each facility is expected to reduce approximately 1 million tons of CO2 per year and generate significant amounts of clean energy as well as clean water. And so that's the technology piece. I'm not going to go into SWEEP because I want to basically just to suffice it to say that SWEEP is an environmental performance standard, and it's going to be piloted starting in 2020. If people are interested in contributing to SWEEP, go to the sweepstandard.org, look around, send us a note, and we would be happy to tell you more about the system and get you all involved. So I'm happy to take next 10-15 minutes worth of questions.
Okay, thank you, Rob, for that great presentation. So we're now going to field some questions for Rob. Again, if you have a question, please use the Q&A feature on your control panel. And I think we have one already. So this question was concerning in the beginning of the presentation, the slides about the waste types. And this attendee states a couple of problematic waste types come to mind, like dirty diapers, Tetra Paks, and composite materials. Can EcoHub handle these and how?
Okay, so that's a tremendous question, and you know, the material stream is always changing, and so one of our biggest challenges is to make sure that we don't overinvest or underinvest in different kinds of materials. So as it turns out, P&G has developed a diaper recycling technology which they've implemented in Italy, which, bless the Italians, they actually collect diapers separately from everybody else. Now, obviously, that would never work in the United States, but because we get everything in the waste stream, and basically, you know, people are not going to leave open diapers in their own waste buckets. They basically tape them up like little cantaloupes, and so when these little cantaloupes come out of the, you know, once they come out of the bags, they're not that hard to separate. So we basically get all of the diapers, and then we put this into this patented P&G process, and they're one of the key people that we're talking about. And then things like Tetra Pak and composites absolutely represent a challenge. You know, with multi-layer foils and stuff like that. You know, some of the technologies that look promising look at like microwave pyrolysis, and these are going to be as they're probably going to get more as they become more common. You know, these are the kinds of things that the molecular constituents reactor are going to do very well at separating the various and sundry atoms. So basically, once you separate, you know, with the combination of heat and pressure, the carbon, hydrogen, oxygen, and makes up the plastic / organic pieces of it, what you'll have left are the metal metal foil components, which will be easy to you know, separate and turn into things. So, you know, we're and then Tetra Pak, you know, it's not the main challenge there is not that they can be separated. It's just it's hard to get enough of them to do the kinds of processes that can separate them at scale. But because we get them all, we're able to put the back end technology on. It's a pretty small piece of it, piece of the, you know, total tonnage, but we're going to be looking a lot more into that as it gets increasingly introduced, because it, you know, it has a lot of benefits, both from a life cycle materiality basis and food preservation, et cetera. So while it might be slightly more difficult, it might end up in a thermal conversion process, or, you know, something where, you know, we're skimming the plastic out of our paper making, and because we've got the polycoat anyway that we're going to have to deal with in paper, you know, we'll get better at it. I'm not going to say that, you know, we've got that completely licked, but it's a very small piece of the puzzle right now. And you know, one of the things I didn't mention was that we're going to have a center of excellence at each of the EcoHubs, and part of the center of excellence, which will be run by IBM, is researching things that you can do with discarded materials. So hopefully, you know, we will be increasingly looking at composite materials and looking at how to design things for you know, recovery and disassembly, et cetera.
Yeah, here's a couple more items mentioned, and you just mentioned cups, coffee cups, but the polycoats, and also things like granola bar wrappers, you know, the lightweight films used for packaging. Right. Something like that. Yeah, so again, I mean, you know, as a total fraction of the waste stream right now, I mean, it's obviously getting lighter, and these things are becoming more and more important. And really, it's basically figuring out how to separate the organic from the inorganic. And you know, our second generation technology, which is the molecular constituents reactor, will probably be the way
as these materials, become increasingly frequent, are likely where we'll go. But like I said, things like pyrolysis and microwave pyrolysis are ways of doing it right now. I don't like putting thermal treatment onto things. That tends to be a bad way of extracting value. I'd say based on my research, 85 to 90% of the material stream has significantly higher value if you try and keep the constituent parts together. But then when you start getting into the next generation technology, then it actually becomes more valuable when you break it down into carbon and rechain that carbon into fiber and stuff like that. But for our first generation technology, we're going to try and keep fiber as fiber, plastic as plastic, et cetera.
Are there any changes that you see necessary in packaging and material development that would increase the efficacy of the project?
Well, this is from if you look at it, I mean, so if we're looking at it from a recycling perspective, a lot of the trends in packaging are highly problematic. But if we're looking at materiality and all of the constituent energy and resulting pollutants and total amount of materials going into packaging, from a recycling perspective, those trends are very problematic. From an environmental perspective writ large, they tend to actually be quite favorable because the materiality is so significantly less and the packaging is so much more durable that, on a life cycle basis, even though they're, quote, not recyclable, or at least not conventionally recyclable, you'd have to use so many more. It ends up, being bad for recycling, but better for the environment, even though that might on its face seem a little contradictory. So, clearly we want to be able to figure out the circularity of multi-layer packaging. And it's not a huge problem right now. And again, it's probably the kind of thing that under our current thinking would be treated thermally. If that's not permittable in a jurisdiction, then we would probably end up doing some sort of downcycling into like doorstops or something like that. But obviously we want to try and go highest and best use, and that will that'll just vary depending upon what's permittable, both politically and from a sort of a local regulatory regime perspective.
Is chemical recycling a part of your technology?
Yeah, so the short answer is yes, and I've seen a lot of different definitions of what chemical recycling means. Some people look at pyrolysis as a quote unquote chemical recycling technique. I'm like I said, pyrolysis I think makes sense for about 10% of the material stream, but not for much else. We're looking very closely at some of the depolymerization technologies, like, for example, the stuff that IBM has come up with, and our ability to get back to that. And there's that very exciting, sort of infinitely recyclable polymer coming out of Berkeley, I believe it was, that's obviously going to be something, and it's something we're absolutely going to be looking at in the Center of Excellence. So that the short answer is yes, and we'll be approaching it as appropriate.
Okay, this attendee describes he took apart a defunct coffee maker and found that each of the body parts, the plastic parts, had the chasing arrow symbol on it. So basically, he mentioned that these parts could be recycled in their local program because they accept number 7 plastics. Mm-hmm. But the question comes out that does this system allow for disassembly or having like handicapped people or convict labor disassemble items?
That's a terrific question, and absolutely, and I love where that person's going with this, because one of the things we want to do with EcoHub is change people's relationship with waste, right? It's not waste, it's materials at a different part of its life cycle. So with things like furniture and electronics, we want to be able to, we've got the ability, because we're getting them all, we have the ability to take them out of the waste stream. And obviously some things are going to be repairable and some things are not. If they're repairable, we might have a program where people can come in, learn a skill about electronics repair, and walk away with a new electronic, thingamajig. Similarly with furniture, if it hasn't been completely trashed, people can learn how to recover or refinish and walk away with a piece of furniture. So we want to have this, and we want to have makers labs. We want to create, recyclable content inks that people can, make thing in 3D printers. So we want it to really be, we want to change the whole ethos around garbage and turn it into materials and circularity, and recognize that it's a clean industry, not a dirty industry, one that's restorative, not just sort of sweeping things into a corner. So excellent question, and we're absolutely on top of it.
What is the typical footprint of an EcoHub? So
2,000 tons a day would require 40 to 50 acres. There are ways we can consolidate it a little bit, but we would look to 40 to 50 acres. We would love to restore old industrial sites. We want to recycle buildings as much as possible, and we can have sort of a hub spoke sort of thing where we have the max diverter and maybe a couple of back end technologies on 15, 20 acres, and then other things within 5 or 10 miles where we could, maybe take truckloads of bales and stuff like that for processing there. But ideally it would be all on one campus. But that's the basic footprint. And there are economies of scale. As we go, if we wanted to do something that was bigger, we would, 2 EcoHubs would, require 70 to 75 acres instead of 80 to 100.
Okay. Are all of your EcoHubs in response to a government or an authority request for proposals, or are they private sector driven? I guess, what's your typical project? Is it? Yeah,
so right now, everything, most municipal programs go through an RFP process because, there's typically some form of municipal dollars being used. We don't have any full EcoHubs built yet. We have our proposals into several RFPs, RFIs, and so we're hoping that RFPs get written that allow innovative technologies to compete fairly against existing technologies, because we sort of have a case of a potential success versus known failures in most cases, because sending more trucks and everything like that isn't going to do it. It's going to break the bank. And EcoHub is basically taken existing materials, sequenced it in a new way, and we believe that the sequencing is the only way that you can get the 75% plus diversion that a lot of people are asking for. But a lot of the RFPs are not really designed for our approach, and so we don't end up doing as well as we should.
Right. Okay, looks like that's it for the questions. So we're going to wrap it up. So again, this webinar, like all the webinars in this series, has been recorded and will be made available via YouTube links on both the National Recycling Coalition and Pennsylvania Recycling Market websites. Thanks again for joining us. We hope you'll join us for next month's webinar, and please visit the NRC and RMC websites for schedule updates. And thank you, Rob, for their second presentation. It was really interesting.
Thanks for having me, Wayne. Look forward to more.
Okay, have a great day.
Okay.